Alright, so this video will take you through the questions on the final exam that deal with Chapter 1. Alright, so here's our first question that you'll come across on the final exam. Notice what it says here. Determine which of the following expressions, following equations are equations, right, that are linear equations, okay? And notice it says linear equations in X, right? So these must be linear equations in X. Basically linear equations in only one variable, okay? So let's just, let's write them out here. Okay, so we got them all written out there. So let's just consider out what a linear equation is, right? And we'll consider that down here at the bottom. Remember, our definition of a linear equation in X will take on this form right here, ax plus b equals 0, right? And in addition, the exponent of the X variable will be raised to the power of 1, okay? So basically those two conditions there that you can really kind of test things out about whether or not it's a linear equation. So the idea would be that can you write these things in that way? Notice what we can do with this first one here is combine our like terms here. 4x plus x is 5x, and then we could add this -2, and that is equal to 0, right? So actually what we have there is a linear equation. So that one is a linear equation in X. And this other one is 16 equals x squared. Notice this right here, right? That is raised to the second power. So that is not a linear equation. It's actually a curve or a parabola. It's not a linear equation, so that one is not a linear equation. Then this other one looks kind of what we're talking about here. 9x minus 4 equals 9. But we can play around a little bit with this and actually put it in that form. So we got 9x. Then if we were to subtract the 9 from both sides, we would get 9x minus 13 equals 0. And we could do something like this to make it even further, like that particular example there down at below. So this one is a linear equation, adding a negative basically there. And then this last one, it is a linear equation. It is a linear equation. You might be tempted to select this one. But remember, it's got the y there. And it's specifically asking for linear equations in X here. Basically, this is a linear equation, but it's in two variables. What we're looking for is a linear equation in one variable, and specifically in X. This one is in X and Y. Granted, it is a linear equation, but it's not a linear equation in X. It's very important to distinguish between those two things there. All right, so this next one here will say to solve the equation. Okay, solve the equation. All right, so I got it written out already. So remember the idea when you solve equations is to isolate the variable to one side and the constants over to one side, the other side, combine any like terms, and then the final thing would be to divide or multiply by the coefficient of x to get our solution. Okay, so let's go ahead and subtract 2x from both sides here. All right, so I got -3 equals 8x plus 21. All right, so now I've got the variable x over to one side, but now I had to get the constants over to one side. So I would subtract 21 from both sides, and I got negative 24 equals 8x. And then now I want the coefficient of x to be 1. So to do that, I'll divide both sides by 8, and I got x equals negative 3, right? And remember, our textbook wants us to write this as a solution set. So our solution set here would be negative 3. All right, so again, it is asking us to solve here, right? Solve the equation. All right, so same concepts here. Isolate the x variable, combine it into like terms, get the constant over to one side. So the first thing we're going to have to do here, and I'm going to write all this out, is do 6x minus 10x, which is combining like terms there. We get negative 4x. All right. All right. So now I'm going to add the 4x to both sides, isolating the x variable. So I got 6 plus 2x equals 16. All right. Now I'm going to subtract the 6 over from both sides because I want to get the constant over to the other side of the equation. So I got 2x equals 10. So now I would divide both sides by 2. Dividing both sides by 2, I got x equals 5. And again, remember we write that as a solution set. There. So solution set is 5. X equals 5. All right, so this next one is about solving an inequality here. And remember, when we do inequalities, our solution has got to be in interval form. This one, when you're doing the practice test, it'll say both interval and graph form. Actually, on the final exam, you'll only have to do the interval form. But, you know, while you're doing the practice test, it would be good to go ahead and think about the graph as well. So anyway, let's go ahead and work this. Let me show you what the easiest way that I think to do this one here, and that is to move the x terms over to the left and the constant terms over to the right. So what I would end up doing there would be adding 4x to both sides, and then I would add 9 to both sides. All right, and what I would end up with here is 12x greater than or equal to 9, right? So now it's really already in the way that I want it to look, with the variable on the left with the inequality there. Then I would divide both sides by 12 here. So I would get x greater than or equal to 9 twelfths. All right, I'm going to throw in a little bit of review. But we're going to basically use the fundamental property for rational numbers here. That is to cancel out any common factors. So let's just kind of rewrite 9 as 3 times 3. And then let's write 12 as 3 times 4. Right? And then our common factor of 3 would cancel out here. So what we would end up with here is x greater than or equal to 3/4. And as I said on the test, it's not going to ask you for the graph, but sometimes it's good when you're trying to write the interval here to think about the graph. So basically we've got a bracket because it's greater than or equal to. And since it's greater, it's going to go to the right. So basically there's the graph. So in interval notation, this would be bracket 3/4 to infinity, okay? And now, as I said, I wanted to show you a couple of ways of doing this. But if you end up working it in this other way, there's a couple of things you definitely need to remember. For example, so let's say for whatever reason you decide to subtract 8x from both sides first. So you've got negative 9 greater than or equal to negative 12x, all right? So something's going to happen here. So notice I'm dividing by negative 12 on both sides here. Now I'm dividing by a negative value. So, and remember, when I do that with a inequality, I've got to reverse the sign. So 9/12 is going to be 3/4 again, but I've got to reverse the sign. So now it's going to be this direction here, right? And but typically what we think about these inequalities, and they're kind of easier to think about whenever you put the variable on the left. Remember, the greater than or equal sign goes towards the x. So anyway, notice we ended up with the same situation here, same inequality. And then again, that is the interval for this. All right, so that's the questions on the final exam that relate to Chapter 1. Go on to the next ones and you'll see the other chapters that we've covered